Hi folks, we're going to take a look at part B from number 2 on more optimization problems. Let's just remind ourselves what we did in part A. So we had to maximize the revenue and we wrote an equation for revenue with respect to this new variable x, which was the number of price drops. And with that we were able to then solve the problem. Here what's different is that we're now bringing in the cost and we're trying to maximize profit. So the question is maximizing revenue necessarily going to also maximize cost? Okay, so first thing we have to do is be precise about what function we're going to be using. So here we're trying to maximize profit, and profit is given by the revenue you take in subtracted by the costs it takes to produce and sell those products. Okay, so now the revenue will be the exact same function because you're still making money in the same way. You're still selling items at a particular cost. Okay, we're still working with that same research which shows that for every price drop of $10, the sales will increase by 100. Okay, so the revenue portion of this equation will be the same as what we used before. So 1,000 plus 100x and then multiplied by 450 minus 10x, keeping in mind that x is the number of price drops. Okay, so let's take a look at what the costs are. So here we see that there's a fixed cost, okay, that doesn't depend on how many televisions you're making, so that's the $68,000. And then there's a cost that does depend on the number of televisions you're making. That's the $150 per television. Okay, so if we want to try to figure out the cost, which we're going to be subtracting, let's see if we can come up with an equation. So this $150 is per television. So we need to multiply 150 by the number of televisions that we're selling. Okay, but we already have an expression for the number of televisions that we're selling based on that same variable x. That's our 1,000 plus 100x. So here I'm going to reuse that. So it's going to be 150 times the number of televisions, which is 1,000 plus 100x. Okay, and then of course I have to add to that the $68,000, which is a fixed cost, does not depend on the number of televisions. Okay, so we see here that if we were to multiply this out, this is just a linear function. And then we've got a quadratic minus a linear will just be again a quadratic function. Okay. Notice here I put big brackets around the cost because I need to subtract all the terms that might come into play. Okay, so this is one way to set up an equation. Okay, this is probably the one that's the most straightforward. If we'll probably take a look at the very end of this video. Another way we could have set up this problem. Okay, requires a little bit of thought, but in the end actually gives you something that's a little simpler to work with. Okay, now before we were able to solve the problem because it was already factored. We don't have that scenario here because this is not in factored form. So it looks like here we're going to have to expand this out, and since we'll have it in standard form, probably makes more sense to complete the square. So let's do that here. Okay, so here we have 1,000 times 450, so 450 plus another 3 zeros. Okay, and then we've got minus 1,000x times 1,000 times 10x plus 100 plus 450. So I think that one there, I will take my calculator for that one there. Okay, so here we've got, let's move that around so that you can actually see what I'm putting into the calculator. Okay, so here we've got 1,000 times negative 10, so 1,000 times, whoops, 1,000 times negative 10. Okay, and then we're adding 100 plus 100 times 450. Okay, and we're left with 35,000, so plus 35,000x, and then 100 times negative 10 is negative 1,000x. Okay, and here we're subtracting, well, 150 times 1,000, so 150,000. 150 times 100, so plus 15,000x, and then plus 68,000. Okay, and let's see if we can simplify this all at once. So the only squared term we have, sorry, this should have been 1000x squared. Okay, so for this last, okay, so here we've got negative 1000x squared. Here we have a 35,000x minus 15,000x, so it looks like that's going to give us minus 20,000x, and then we've got 450,000 minus 68,000. Okay. Oh, and of course the minus 150,000. Okay, so we got 450,000 minus the 150,000, and then minus the 68,000. Okay, so in the end, plus 232,000. Okay, so now that we've got it in standard form, we can now complete the square. So remember, to complete the square, step number 1 is to factor out whatever comes in front of the x squared, so negative 1,000. So here we're left with x squared. This is going to be minus, since we're factoring out a negative number. So this is 20,000 divided by 1,000, so that's just going to be 20x. Okay, of course we only do that with the first two terms. We'll deal with the 232,000 later on. Okay, so inside the bracket, we go ahead and complete the square. Now at this point here, you might be starting to skip some steps, so I'll show a whole bunch of steps, but not necessary for you to show all these steps. So this is x squared minus 2 times 10x. So here we're going to add 10 squared, subtract 10 squared. Okay, so negative 1,000. So here this now becomes x minus 10 squared. Okay, and then we have the minus 100. Now at this point here, I might make a little comment that when we look back at the question, all they want to know is what price and how many units need to be sold. So we realize that we already have that x value of the vertex here. Okay, all the rest of what we're doing here would be to determine the actual maximum value, the maximum profit. I'll go ahead and continue, but if you're on a test and you realize that that's the only information you need, you can just stop there and use it. Okay, but let me go ahead. So now I'm going to distribute. Make sure you do that to both terms. So negative 1,000 x minus 10 squared, and then this is going to be 1,000 times 100, so plus 100,000. And now finally we can clean this up, and too many zeros there. Okay, so negative 1,000 x minus 10 squared, and this will give us plus, looks like 100,000, so $332,000. Okay, so this is the maximum profit. Okay, but we see here that the number of price drops that we need, okay, the x value of the vertex here would be 10. Okay, remember that in the previous question we had to do 17.5 price drops to maximize revenue, but to maximize profit based on this cost function, you need 10 price drops. Okay, so again, go back to the question. It says here, determine the number of televisions and at what price. Okay, so again, the number of TVs, okay, is given by this expression here. Okay, so 1,000 plus 100 times 10. So here it's 1,000 plus 1,000, so it looks like it's $2,000. Sorry, 2,000 TVs is what you should expect to sell. And for the price per TV, well, that's given by this expression here. So 450 minus 10 times 10. So 450 minus 100, so $350. Okay, so we see that earlier, to maximize revenue, made sense to charge $275 and sell 2,750 units. Okay, just realized made a little mistake there. Okay, and for maximizing profit, it's $350 at only 2,000 TVs. Okay, so let's just recap here what we did. Okay, we created a revenue function just as we did before based on the number of price drops, and another type of question could be the number of price increases, and then we subtracted a cost function which we try to create so that it uses the exact same variable, so that in the end I've got a profit function that is based on only one variable. Okay, now this is a typical way to set up this type of problem. I did allude to the fact that there was other ways of dealing with this, so you might want to think about some other ways of setting up a problem like this. Okay, that's it for this one.